All right, the second example is pretty much the same as the first one, but we will go ahead and do it anyways because we want to practice the steps. And again, with these problems, you're going to want to practice this. This is the only way to do this, to recognize what it is when you see it from outer space, to recognize it's the product rule and go, oh, crud, it's a product rule and integral. It's going to be a backwards, probably a integration by parts problem. And then to remember what the steps are, and the steps are, this is the way, do the problem, do the problem, do the problem. If you make a mistake, you need to recognize what the mistake is ahead of time. So we're going to practice these by doing them, and you're going to want to practice these for sure later on. All right, so I got two functions. So first thing is, can I do this without anything? I set u equals 6x, I get 6. That's not an x, can't solve that problem. I set u equal to e to the 6x, I get e to the 6x, 1 to the 6, that's just not going to do the job. So bottom line is it won't work. Is it two functions multiplied together? Yes, and we should probably do this. So first thing I do, I find what is more complicated. I say, well, dv looks more complicated to me, so I'm going to write dv is equal to e to the 6x dx. So then when I go, when I want what v is, I integrate both sides. Integrating this is going to require u substitution, which is a little tricky, so I'm using too many letters. I'm going to go w substitution equals 6x. So it would be the integral, so dw equals 6 dx, right? And so I end up with, I need a 6, so I go e to the 6x dx. I need a 1/6 out in front and a 6 right here, which I've now made. So v would therefore equal 1/6 e to the, integral of e to the u du, which is 1/6 e to the u plus c, or v equals 1/6 e to the 6x. Now I'm going to drop the plus c. We're going to need a plus c to solve this thing at the end of the day. Okay, so it's really not that important. But I need this v, because this v is going to be handy to me in just a second. And I need this dv, which I have right here. So those are the two things I need. Remember, I'm going to write uv minus the integral of v du. All right, so that's the first step. So now I chose my v, so now I'm going to set my u equal to what's left over. The other expression is the x over here, so I'm going to go x. So du equals 1 dx. And those are my two expressions I need for the rest of it, right? So now I'm going to write the integral of x e to the 6x dx is equal to, actually, you know what? Let's do it this way. Let's show the integral of v du equals uv minus the integral of v du. Whoops, did I do that wrong? This should be u dv. Yeah. Okay, I learned it backwards from the way everybody else in the Western world does it. I don't know why. Anyway, so I checked it. I got integral. U was x, so I'm good there. dv was e to the 6x dx. I like that. That's fine. Equals, now I need uv. So u is x. V is 1/6 e to the 6x. Minus integral of v. What's v? V is 1/6 e to the 6x du, which is 1 dx. Now look at this and go, that's doable now, right? It's going to be the same silliness. I'm going to still use w, right? So this is going to be same problem with w. So I go w equals 6x. dw therefore equals 6 dx. That looks good. I'm all set up. I'm ready to go. So now I'm going to go ahead and integrate this again, and I get, I'm going to clean this up while I'm at it. I got 1/6 x e to the 6x. Hard to read that. Sorry about that. And then I got 1/6 out in front. I need another 6 dx, so I need another 1/6. So I put another 1/6 out in front. Integral of e to the 6x. Now I'm ready to turn into w's. So this becomes 1/6 x e to the 6x minus 1/36 e integral e to the w dw. And recognizing what that is, that's just going to be e to the w. So x e to the 6x minus 1/36 integral of, nope, I gotta drop the integral. I've already done the integral. Where's my eraser? There's my eraser. This is gonna take a while here. Whoop. So this just becomes e to the w plus c, and then my final line looks something like 1/6 x e to the 6x minus 1/36 e to the 6x plus c, and I circle that up. Now one or two of you should hopefully be thinking, well, what about this c that you just casually got rid of over here? Well, look, I could have a plus c in here, and all that's going to happen is going to end up over here anyways, right? So I'm taking care of it already. It's not a big deal. And so therefore we just drop it as we're moving along. There's no point in messing with it there as long as I still have an integral that's going to appear later, which I do. Okay, and that's going to be taken care of when I deal with that. Got it? All right. So here's what I'd like you to do. I'd like you to write the example to number 3 on the top of your paper at some point, and I'd like you to go ahead and try example number 3 right now. And then I'm going to show you the answer. I'm going to kill some more time on here, whistling something or whatever, or pause it. Actually, you're going to need to pause it, and then when you pause it, and I'll do example number 3 with you on the other side of this one. And okay, all right. Alrighty there. Here we are at the Fun-Filled Festival of Fun. We look at this problem. We go, all right, I got two things multiplied together. No, I'm doing this outside of it, although you could distribute the cosine through. If you distribute the cosine through, you still end up with a problem because w is going to have to be t over 4, and then dw dt is going to be 1/4 dw, and no way you can make the 5 do that, but the 3t isn't going to do that. So you end up having to do a integration by parts anyways. So we're just going to go ahead and do it from the beginning, which is, if I look at it, what's the ugly part? Well, the ugly part I really don't want. The very ugly part is going to be cosine of 1/4 t dt, right? So if I integrate this, I'm going to set w equal to 1/4 t. So dw equals 1/4 dt, right? Now I'm being a little pedantic here. If you can see this and you don't want to go through all these steps, feel free to not go through all these steps, right? So the integral dv is equal to the integral of, I need a 1/4 dt, so I'm going to put a 4 out in front, and I got my cosine of 1/4, really that's a 1/4 t. All right, so then I look at this and go, integrate this, gives me v over here, which is what I'm looking for. What gives me positive cosine? Sine does, right? Oh, I shouldn't do that. I should change it to w, shouldn't I? Sorry about that. Oh, and do it at the same time. W, dw, right? And then what gives me cosine? Sine gives me cosine, so I can get rid of this integral sign that I just drew. Sound effects for those of you who want to make sure it's me. And then I've got, so I get sine w, and w is just 1/4 t. And again, we're just going to drop the c because we're going to pick it up later, and we know we're going to pick it up later. So there's v, and there's dv. So u has to be the other thing, and that's 3t plus 5. So du equals 3 dt, doing the derivative like we always have been doing it all along. And there's that one, and there's that one. All right, so now we write out our expression, integration by parts. The integral of u dv equals uv minus the integral of v du. And I start plugging things in. The integral, therefore, of u is 3t plus 5. Now this left side, probably at some point you're going to get bored of writing this down because you know that's what you were doing, and why would you write it down every time? But sometimes it's not the worst thing to take a look and see, did I actually do what I thought I did? And then uv. So u is 3t plus 5. V is 4 sine 1/4 t, right? I probably parentheses around that, minus the integral of v, 4 sine 1/4 t. I'm going to have to fix that. Okay, so we'll go ahead and go down another level. I hope that doesn't bother anybody. It's up late at night. Shouldn't be up late at night doing this. Get a good night's sleep. It's good for you. World's smallest eraser. Okay, and so then minus, and then I'm going to get the integral of 4 sine 1/4 t dt, du, right? Du is 3 dt, right? So I'm going to go 3 dt. And so the left-hand side is good, so I'm just going to go ahead and write equals sign. I'm going to keep the, all right, 12t plus 20 to clean up the 4 that's sitting there in a weird spot, sine 1/4 t. Okay, and then minus, and then I'm going to integrate this. To integrate this, I'm going to set w equal to 1/4 t, so dw equals 1/4 dt, right? So I'm going to draw a little line over here to sanction that off. And so I need a 1/4, so I'm going to need a 4 out in front. So I already had a 4, so 4 times 4 integral. And then I'm going to do sine of 1/4 t. I have a 3 as well. Let's pull the 3 out in front. Pull the 3 out in front. 3's out in front as well. And then 1/4 dt. Agreed? And then I look at this and go, all right, well, let's clean. We're almost done. This first part's going to be still ugly. 12t plus 20 sine 1/4 t minus 3 times 4, 12, times 4 is 48. And this is the integral of sine w dw. All right, so since I got sine dw dw, I know what the cosine of sine, so what gives me if that? It has to be a negative cosine, right? So negative cosine w plus c. And then, so then my final answer is going to look something horrific like 12t plus 20, parentheses should have been on it up here as well, by the way, whoop, sine of 1/4 t plus 48 cosine w. Now you have this negative 48 times c, but as we know, negative 48 times c, well, c is any number, so it's still just a plus c, and I don't have to worry about that at all. And here's my lovely expression at the very end, and what my final answer for the integration by parts is. Okay, so hopefully you're getting this a little bit better. We are about to start the advanced version of this, which is what it's called repeated use of the integration by parts, and that'll be in my next video. If you want to, you could look at example 4 first, start the problem, get stumped on a separate piece of paper, and then I'll walk you through what happens in that case. Okay, so that's example number 4 we're about to start. Got it? The first example number 4. Apparently there's 2 example number 4s.